This is the review for the Chapter 9 test, Part 1 on vectors. Number 1 on page 587, number 15, gives you 2 points on a vector. P is 5, 3, and Q is 1, 0. P is generally our initial point on our vector array, and Q is normally our terminal point. So when we want to write the vector for PQ, we're going to do terminal minus initial of the x coordinates, terminal minus initial of the y coordinates. So we find out that the vector is -4, -3. However, if you want to write this in ij form, you would write -4i minus 3j. Either form is acceptable. We can perform simple operations on vectors just like we do simple operations for real numbers. So if we want to find 2 times vector u, all you have to do is multiply the vector by 2, basically distribute the 2, so you get 4, 14. To find -3v, you multiply both the components by -3, -9, -3. When you're adding 2 vectors, you add the x components, you add the y components, so you get the vector 5, 8. For 3u minus 4v, I'm going to do a little bit more work just to make sure I don't mess it up. I'm going to first find 3u, which is 6, 21, minus 4v is going to be 12, 4. Now I'm going to subtract those. 6 minus 12 is -6. 21 minus 4 is 17. So 3u minus 4v would be -6, 17. When you see what look like absolute value of bars around a vector, it's not really the absolute value. It's the magnitude, it's the length. And finding the magnitude is very easy. So on page 587, number 37, vector u is 2i plus j. Vector v is 3i minus 2j. So to find the magnitude of vector u, I'm going to do the square root of 2 squared plus 1 squared, which is going to give me the square root of 5. The magnitude of v is going to be the square root of 3 squared plus -2 squared. Don't forget, when you plug in a negative number and you square it, it's going to turn into a positive. So I get 9 plus 4, which is 13. The magnitude of 2u, well, first I'm going to find out what 2u is. 2u is going to be 4, 2. So then its magnitude is going to be the square root of 16 plus 4, which is the square root of 20, which is 2 square root of 5. 1/2 v, first I'm going to find out what 1/2 v is. It's going to be 3 halves and -1. Now I'm going to go find the magnitude of it. So I'm going to do the square root of 9/4 plus 1. Which is going to be the square root of 13 over 4, which is equal to the square root of 13 over 2. The magnitude of u plus v, first I have to add u and v. When I add u and v together, I'm going to get 5, -1. Then its magnitude is going to be the square root of 25 plus 1, which is the square root of 26. U minus v is going to be -1, 3. Now I'll find its magnitude. It's going to be the square root of 1 plus 9, which is the square root of 10. On page 587, number 41, in order to find the horizontal and vertical components of the vector given its length and direction in I and j form, we're going to use, I should rewrite that, it's going to be the magnitude of the vector times the cosine of theta, comma, the magnitude of the vector times the sine of theta. This is very reminiscent of when we did polar coordinates. So I'm going to do 40 cosine of 30 degrees, comma, 40 sine of 30 degrees. Cosine of 30 is square root of 3 over 2, so I'm going to get 20 square root of 3 for the horizontal component. And the sine of 30 degrees is 1/2, so 40 times 1/2 is 20. In ij form, it's going to be 20 the square root of 3i plus 20j. In problem 5, number 47 on page 588, we want to find the magnitude and the direction of the vector 3, 4. So magnitude's easy. Magnitude, we just do the square root of, I should write this, it's 3 squared plus 4 squared. So we're going to find out that the magnitude is 5. To find the direction, though, we're going to use a similar formula to the one we used when we talked about polar coordinates. We're going to do the tangent of theta is equal to y over x. So the tangent of theta is 4 over 3. So we're going to find this by doing the inverse tangent of 4/3. And we're just going to round the angle to the nearest tenth, is usually a good thing to do. We're going to find out that it's 53.1 degrees. In problem number 7 on page 596, we're given vectors u and v, and we want to find the dot product and the angle between these two vectors. The dot product is always going to result in a scalar quantity. The dot product is very easy. You multiply the x components together, and you add to that the product of the y components. So you get 6 plus 7, which is 13. To find the angle between the two, this is a formula that I will need to give you for the test. It's the dot product divided by the product of their magnitudes. So we already found the dot product. It was 13. The magnitude of u is the square root of 4 plus 49. So that's the square root of 51. And the magnitude of v is going to be the square root of 9 plus 1. So that's the square root of 10. You can multiply these. Oops, that's not 51. Let's try that again. Sorry, that's 53. So you can multiply these together if you want. If you want to write this as 13 over the square root of 530, that may make you feel better. Because now you're going to do the inverse cosine of 13 divided by the square root of 530. Just be careful how you plug it into the calculator, and you should find out that the answer is approximately 55.6 degrees. Vectors in 3 dimensions worked just like vectors in 2 dimensions. In page 602, number 3, I want to find the vector A if the initial point P is 3, 1, 0 and the terminal point Q is -1, 2, -5. So to find this vector, I'm going to do terminal minus initial. Terminal minus initial is going to give me -4. Terminal minus initial, 1. Terminal minus initial is -5. So the vector defined by those 2 points is -4, 1, -5. In 3-dimensional vectors or geometry, we have spheres instead of circles. And so we found out that the equation of a sphere was awfully similar to the equation of a circle. It just added one additional dimension, which was z. So on page 602, number 15, I want to find the center and radius of this sphere. The way that we did it was the same way we did with a circle. We use completing the square to turn this into an equation that I can extrapolate the center and radius from. So we put the x's together with a blank. We put the y's together with a blank. We put the z's together with a blank. And that's going to equal 9 plus, and then there will be 3 blanks. Because we're going to add 3 additional numbers to the left-hand side, so we're going to add 3 numbers to the right-hand side. How do you figure out what goes in the blank? You take this number, divide it by 2, and square it. So this should be 25. 2 divided by 2 is 1, 1 squared is 1. 8 divided by 2 is 4, 4 squared is 16. So now I'm going to put these in factored form. So the first factor is x minus 5 squared. The next one is y plus 1 squared. The third one is z plus 4 squared. And that's going to equal 51. So the center of this sphere is going to be the ordered triplet 5, -1, -4. Remember that the general formula has a minus sign already here. So you're basically telling me the opposite of H, K, and L. And then the radius is going to be the square root of 51. On page 608, number 7, we give you a vector in 3 dimensions, and we give you the initial point of the vector. We want to find the terminal point. Well, I don't know what the terminal point is, but I can call it XYZ. So we know that we find the vector by doing the terminal minus initial, and that's going to equal the component from the vector. So x minus 2 must equal 3. Y minus 0 must equal 4. And z minus 1 must equal -2. And then all we have to do is find those 3 coordinates. So x is equal to 5, y is equal to 4, and z is equal to -1. So the terminal point must be 5, 4, -1. Now, be careful. The terminal point is not a vector. Make sure that it's in parentheses and not written as a vector. Page 588, number 53. A man pushes a lawnmower with a force of 30 pounds exerted at an angle of 30 degrees to the ground. Find the horizontal and vertical components of the force. So the force is being done at an angle, and the 30 pounds is the magnitude of the force. And I know the angle. So to find the horizontal and vertical components, we're going to do the magnitude of the force times the cosine of the angle, comma, the magnitude of the force times the sine of the angle. And that's going to be your horizontal and vertical components. So the cosine of 30 degrees is square root of 3 over 2, so that's going to give me 15 square root of 3. That's my horizontal component. And the sine of 30 degrees is 1/2, so that's going to be 15. That's my vertical component. On page 596, number 25, vector u is 4, 6, vector v is 3, -4. We want to find the component of u along v. Well, the definition of the component of u along v is the magnitude of u times the cosine of the angle between the two. But in order to do this, I can find the magnitude of u really easily. The magnitude of u is going to be the square root of 16 plus 36, which is 52. But to find the angle between the two vectors, I would have to use this formula. And it tends to get a little daunting. It turns out that this is an easier and faster way of finding the component of u along v if you know the two vectors. First, I'll find the dot product. U dot v is going to be multiply the x's plus multiply the y's. So I find out it's -12. The magnitude of v is going to be the square root of 9 plus 16, which is 25, and the square root of 25 is 5. Well, it turns out the answer is -12 over 5. I actually could get the same answer doing it the long way by putting the square root of 52 here and multiplying that by the cosine of the angle, but I got to get the angle first, and you find out the angle is 109 degrees, so then I could do the cosine of 109 degrees. But this other formula where you do the dot product divided by the magnitude of v was much faster. And that's the end of part 1.